Yes, hello everybody. Welcome at the second day of Future Tech Digital 2021. My name is Sander van der Velde and I'm your host at Room 3. The last session of today is from Heini Ilmarinen. She's a math teacher and turned into an Azure expert on DevOps consultant, and she's working for the Polar Squad. Her session is about Machine Learning 102 beyond the visual tools. So, Heini, take it away.
And there we go, we have sound now. So thank you so much, Sander, for that introduction. I'm really happy to be here today. I've been going around the sessions in these 2 days, and it's been quite amazing content, I have to say, and I've been impressed by the whole setup for this event, so it's really a privilege to be here. So today's session for us here today is Machine Learning 102, and this is really about looking at the first step after going into, for example, Azure Machine Learning and making a machine learning setup with a designer on the visual tool, and what do you need to know to transfer onto using notebooks instead, and when would you do that? So if we really think about machine learning currently, it has become much more easier than it used to be to do things with machine learning. So for example, excuse me, there we go. Within Azure Machine Learning, we've got the designer that will make it very easy for us to create machine learning models. You just take these nice little drag and drop pieces, you put them together, connect some arrows, and do all the steps that you need to do your data. You choose your model, and then you split your data so you can train it and score it, and all the way to actually evaluating the model. So if we really think about this, it really hasn't been much easier than this before to do this. It's really easy now. It's really fast. And most of all, we don't need to know a lot of the math behind the scenes, and we don't need to do any code. So there are really huge perks to this. It's easy, it's fast, it's no code. But there might come a point where this is not enough. We need more flexibility, for example. So that is what we're going to be looking into today. So I'm Heini Ilmarinen. I work as a DevOps consultant at Polar Squad. I'm also a Microsoft certified trainer and run some trainings around Azure as well. My favorite topic is architecture, but I'm also quite a math nerd at heart. I used to be a math teacher until I came into the IT. And Azure Learning is one of my favorite topics because it kind of combines my current work and my past life as a mathematician. And so I get to combine all those skills together and bring that knowledge kind of into one place. And you might notice I am a bit of a serial doodler. There will be quite some pictures here on the slides when we aren't looking at any demos. So what we're going to start today is how to start quick with a designer. And to do this, we need to know that within Azure Machine Learning, there are 3 parts to it, how we can work with it. The first one is the designer, which is this drag and drop interface where we can easily create our first models. There are also 2 other parts to which we will get to more in detail later, but there are the notebooks, and then there is the portion called Azure Auto Machine Learning. So we will start with the designer, and then we will look into these other 2 parts after that. And so I have kind of prepared a bit because we have quite a short amount of time today for this session. So I have created a machine learning service for myself, and I am going to launch the studio here, even though I did have it open there, but let's just navigate here. And in the beginning here and at the top, you can find these 3 authoring options. We have the notebooks, we have the automated machine learning, and we have the designer as well. And so we're first going to start with the designer. I have already prepared a bit, so we don't have to go through all the dragging and dropping. but I will just show what has been done here. In this machine learning designer experiment that we have here, we are working with an open data set, which has diabetes data in it. And so whenever we work with any data, we first, of course, need to start by understanding that data. And so within the designer, the nice thing is that we can take a look at the data that we have available. Sorry. Outputs, that isn't showing me the output somehow. So let's go this way. And within the designer is the nice aspect that we can visualize this data that we have available. And what it allows us to do is it gives us some sample rows from that data set. It also tells us the amount of rows that is present there, and it shows the number of rows. And if we look at this data, we can see that the column values are a bit vague. We don't know what that means. But I will tell you that these S1 to S6 are measurements from the blood. And so we have the age, we have the sex, we have the body mass index, we have the rest of these are blood measurements, and then the Y tells about the tendency to have diabetes within a year of this scientific study that was done. And the higher it is, the more likely it is for somebody to get diabetes. And so if we want to pick any of these items, we can also click on it and we'll kind of see how is that data distributed. We'll see how are the values spread out. We will also see some of the main values like the mean, the median, and minimum and maximum values. Yes.
A short interruption. Can you zoom in a little bit?
Yes, please. Thank you so much.
Thank you.
While I'm on this, I cannot see the chat, so please shout out if there's anything else in the chat either. Is this a good size? Okay, no objections. I'll take that as a yes. So we'll see all these core values about each of the columns, and this really allows us to find whether there's, for example, any missing values in the data set, etc. So we could kind of go through our data set and just kind of ensure that the data is of good value and whether we need to do any cleaning to it. With this particular data set, because it was kind of well prepared ahead of time, we don't have to do a lot of cleaning, but I added a select statement just in case. So you could specify certain columns that you want to choose, and then you can remove missing value rows. So you can kind of take out those. But whenever you're deleting any data, you have to figure out what is the best strategy about that. Just removing rows that have empty values in columns might not be the best option all the time. Then we get to the actual machine learning portion. So we have the first step of which is splitting the data. Here we are splitting 0.7 of the data set, so 70% of the data set to be trained. And then the rest, 30%, is going to be our test data set against which we're going to test the model that we create here. Then we, as the machine learning model here, or the algorithm, we have chosen linear regression, and we can go and check in and see that the method here that is available for us is the ordinary least squares. And there is also another option which is online gradient descent, and that is a slightly different method, but we can just go with this option. And then there is this regularization weight, which really kind of looks at how far it will go with training the algorithm. And then that algorithm will be used to train the model with the 70% of the data that we get in. And within the train model, we're actually specifying which column are we trying to predict. And here we're going to predict the column that was named Y. So this was the number that told us how likely is somebody to get diabetes. And then we're just going to score it. And then as the last point, we're going to evaluate it. And because the compute that is used on these designer sessions, they go idle quite fast. And so I ran this beforehand just in case it happens to go idle before I have the chance to submit it again. So we're going to look at the results before I actually run it. So once we get to the score model point, we can go to the outputs and we can find that visualized here. And so if we scroll to the very right, we can find the scored labels. And so this is the actual value, is the y, and then the scored labels is what it predicted. So we can kind of see that, okay, there's some fluctuation, some values are quite close, some are quite far away actually. And so there's quite a bit of kind of going back and forth whether they actually align with the y column values. And of course, that could be because our algorithm isn't the optimal one, for example, for this case, or we don't have the right kind of variables for our algorithm to run on. But for example, if we look at the mean values of these data sets, they are then very close to each other. I mean, this one and this one. So those fit very close together. And that has to do with how this method of algorithm actually works. But the nice thing is we don't really need to know what is happening behind the scenes, but we should have some knowledge of the algorithms, what is a reasonable one and how it can work, because otherwise we could end up with solutions that are not really predicting the data well, but are actually kind of giving us wrong results because they are not actually being very good at it. So if we then lastly look at the evaluation of the model, we can look at the evaluation results. We can find these mean absolute errors and the root mean square error as well. And we can see that there's still some fluctuation there. And then we can find these other values. So we can kind of use these values now to determine whether this was a good algorithm or not. And then with this graphical interface, it's nice. We could just realize that, okay, we have to change our model, for example. Sorry, wrong place, the top one there. And we could decide, for example, that we need a Poisson regression, and we then just drag it in and put it in the place of linear regression and set that in there. So it's really easy to get going in this method. I'm just gonna submit this, and as you see, when I submit this, it's asking me whether to select an existing experiment or to create a new one. So I have an existing one. I'm going to just let that run underneath that same experiment that I was using previously. So we're going to let that run. You'll see that it actually runs as well. But okay, this time the compute didn't have time to go idle. I've just had that issue previously, so I was kind of thinking ahead of myself. But we should have pretty much the same results on this go as well as here for the evaluation results. Yeah, they're exactly the same. All right, so that's how you can get started really easily with the designer. There's even some templates that you can use and use those, or just start picking your data sets from some of the sample data sets that are available here and start playing around. That's the fun part about the designer. So with a designer, it's really easy to get started really fast. But at some point, it might be that we kind of run across a wall. And in that case, we might start to think like, well, we don't have all the tools available that we need to run our machine learning algorithms in the designer. And in that case, we might need to look at the other options that we have available for doing these machine learning experiments within Azure Machine Learning. And so, as you remember, we have the 3 different parts that are for the authoring. So we can use the designer, we can use the notebooks, or the AutoML. And for the AutoML, you can either trigger it from a notebook, or there's kind of this graphical interface that you can follow along. But to really understand what we can do with notebooks and how we need to set our notebooks up, we need to understand a little overview of Azure Machine Learning itself as well. And just as we were in the designer a little bit ago, you noticed that we had these descriptions of data sets that I showed in the very end. We had some ready-made data sets that we can play around with. But of course, we might also want to bring in our own data. We might not just want to use the data that is available there. So to have some data for our machine learning models, we need to have some kind of data sets and data sources defined. And these we can define within the Azure Machine Learning Studio. Then when we have that data available, then we can use these different authoring tools to build our training setup and choose our algorithms and so forth. But then to run this, so you saw I submitted my designer pipeline that I had, and it was running on something. Actually, under the surface, there's compute there. So there are virtual machines that will then run those, whether it's notebooks or whether it's the designer or whatever it might be in the environment. And then when I run that environment, what happens is that an experiment gets created. So you notice that in the very end, as I was running our kind of setup in the designer, there was an experiment being run at that moment. So to be able to use the notebooks, we also need to consider these different parts. We need to have a data set, and we have to have some compute that it runs on, and we have to have an experiment against which it runs on. And regarding the notebooks, there is the kind of the interesting and fun part that you don't actually have to run the notebooks from Azure Machine Learning itself. Today, that's what we're going to be using, but you could just as well be running them from Databricks or Synapse Analytics or wherever, even from your local laptop, you could be doing the development there, as long as you have the Azure Machine Learning SDKs. There's some SDKs for Python and R, and then you can use those to communicate with Azure Machine Learning Service and even run those, kind of put those experiments to run within the service itself and trigger those from an external service outside. And as we're building the notebook, you will see those different steps within that notebook that will take care of all those portions within this workflow of getting those notebooks running and getting our model trained. So that's kind of the very brief overview of Azure Machine Learning. I will show those parts in the workspace as well in a moment. So we have these two portions, and once we have this overview nailed down, then we can start writing our first notebook. So this is really what we're going to be focusing on next. So we're going to navigate back to Azure Machine Learning Studio. And if we look here, you can actually see all these components that I was talking about here on the left. So we have the authoring section where we have these three different options. Then we also have assets. So we have the data sets that we can use for our designer pipelines or our notebooks. Then as we submit those flows, then those create experiments. And then we could kind of put parts of those together to form pipelines. And then once we have our machine learning model, those can be registered as models here. And then, as I said, we have the compute on which those notebooks can run on, for example. And then these data stores are from within which you can define the data sets. So within the data sets, before we go into our notebooks, we have created a data set of this diabetes data set that we have here. So you can use these open data sets that are available. This is where the diabetes one is from. You can see it here, but there's a bunch of different ones as well that you can use. But you can also use different sources. So within the data stores, you could, for example, define an Azure SQL from where you're going to fetch your data. And so it doesn't just have to be flat files from where you're getting your data from, but you can integrate with many data stores within Azure itself. So this is what I needed to create beforehand to get my notebook to work. So Then we're going to go into notebooks, and I have prepared some of the notebook as well. So we have time to walk through it because there's a few steps to it. So if you think about the designer, there we had those boxes defining each of the steps that we're doing. You can kind of start to think of the notebook in a similar way. But within the notebook, you have these code blocks where you're defining each of those steps. And within this notebook, you're also able to add some commentary. So mine has very little, but if you were working together with a team, for example, you could put in a lot of commentary to really help make it easier to follow along those notebooks that you have created. So to be able to work with Azure Machine Learning, we have to first connect to this workspace. And I really wanted to emphasize this step because if you were working from outside of Azure Machine Learning, you still need to do the connection to the workspace as well. So to run these cells, I can just click Shift and Enter, and those will run. We'll see if this remembers me or whether it will ask me to log in. It remembered me, but if you were logging in for the first time, it would ask you to do this kind of browser login. So it gives you a code and you input that, and then it gives an OK that you are signed in. Then here comes the experiment part. So to run this notebook and have those results outputted somewhere, we need to have an experiment. And to have an experiment, we have to kind of use these libraries that are available. We import from the azureml.car and the experiment side, and that allows us to either get the configuration of an existing experiment or create a new one. In this case, it's just going to fetch the old one, but just as well, we could create a new one as well. So these steps were something we didn't have to do in the designer. They're kind of built in, but within notebooks, we need to do that connectivity. But as the next step, this is something that we did do in the designer. We had a data set that we pulled out, and then we were able to look through that data and see what's there. So I'm just going to get this same data set where it is exactly the same one that we were using in the designer. So this is again available from the open datasets portion. So we just import the diabetes one and we input that into a data frame. And once that data is pulled into a data frame, then we're able to see things from that data frame. So for example, we can run the info one and we can see which columns we have. And we can see how many entries are for each column. But if we want some more information, we can use the describe function. So when we run that, we get some of the similar core values for each of those columns that we were able to see in the designer as well. It's not quite as graphical out of the box, but we get some of the same values. We get the counts, we get the means, etc. And that will give us some kind of ground to start from. So, okay, we have our data set in. Now, when we want to start working with that data set, we need to kind of separate the data that we're using to train and then the value that we're predicting. So in this case, we're going to create two new data sets, so data frames. Where into one of them, we're going to put everything but the Y column. And to the second one, we're going to put just the values from the Y column. And just to ensure that's what we did, we can double check. Okay, we have all the columns up to the S6. And then if we run the next one, we can notice we only have the column Y here and the values for that. So now we have kind of two sets of data. We have the X values, and then we have the Y values as well. And as you can see, it is a bit of coding, and you need to get familiar with the syntax. But, you know, there are these certain steps that you can follow. Like this was kind of doing the separation and defining what are we predicting that we this was kind of a step we didn't need to take in the designer. So that was easier there. So then we need to, that is actually extra. So next, what we need to do is split the data. That was one of the steps we did in the designer. So we need to split the data. And when we use this scikit-learn library, there you define the size of the test data. So in the designer, you specified how much will be in the training set. Here you define the other way around. And just as in the designer, we could have this random state that we add there as well. And so we're going to run that, and that is going to split that data so that then we're able to do the linear regression training. And within the scikit-learn library, we have a bunch of linear models where we can also find the linear regression one. There's a bunch of other ones that could be used as well. So what we're going to do is that we're going to define the model that we're using right here on this line. Then we're going to train that model by using our data. And then we're going to predict what values will that test data side get using that model that we just created in the previous step. So that is all referring to the same model. So these 3 lines are saying the same things as we had in our designer for the steps for having the linear regression algorithm, then doing the training, and then doing the predicting based on that training. So there were the 3 boxes there. And then just as in the designer, we might want to get some core values about whether this was successful or not. Again, we have these ready-made metrics that we can use for the mean squared error and the R-squared score as well. And we can also print the coefficients. And we can, for example, see that here the coefficient determinator was 0.52. And if I go into the designer, for our graphical interface, we can find the same value here as well. It is a bit different for these two. For the mean squared error, this is the root of the mean squared error. So unfortunately, I accidentally put the other measure in the notebook. I just realized. So we would need to take a square root of that to see how close they are. But with these two different methods, we kind of got quite close with each other in these approaches. But I still kind of want to point to you how, yes, in some portions, we need to do a little more work on the notebook side to, for example, find out these mean values, etc. Or, for example, for specifying which of the values we are going to be predicting. So when we, when we kind of split the data in two, whereas then when we were doing the prediction and the training, so the fit is the training and here's the prediction, those are just 2 lines of code. So even while using notebooks, it is these machine learning libraries that are doing all the heavy lifting behind the scenes and doing the magic for you. We don't have to go around and start doing linear algebra to figure out what is the correct answer, but those will figure out the result for you. So what I would encourage you to do when you start thinking about going from your designer setup to your notebook is really kind of think of these cell blocks as these boxes that we have here and start thinking just box by box, how do I go through each step and get to the end result? Of course, when you get to more complex scenarios, there will be more steps added and it will get a little more complex. But if you kind of just follow the same processes, then you will be able to get to a well-structured notebook for your machine learning situation as well. Oh, we have gone through with how to start with a designer and how to design your first algorithm there and kind of take an overview of that side. Then we took a brief overview of Azure machine learning in general. And then we took a look of how to write your first notebook and how to go really kind of strategically and in the same order as before in your designer setup as well, and go step by step and just, even though it's code, just first importing what we need and then using those code snippets for the data to do what we need it to do. And of course, there's so much more to machine learning, like being able to choose the right algorithm or kind of ensuring the quality of your data, etc. But I hope this gave you a little more confidence about, okay, it is still the same steps that are happening in the notebook. Sometimes they just look so different that it's hard to recognize them. But actually, we will be walking through the same steps in the notebooks as in the designer as well. So bravely just start with the designer, get started quickly with that, and then just start bravely going onto the notebook side and going step by step, figuring out which machine learning libraries you want to use and which you need to run a specific algorithm. And there's also a lot of tutorials out there that you can follow along and get started. So thank you so much for joining this Machine Learning 102. And I hope you enjoyed this session. And I think we still have a little more time for some questions if there are any in the chat. And we got the square root result from Mark in the chat. Thanks for that. So yes, we were pretty close with both building this setup with a designer and with a notebook. I was kind of, when I was preparing for this session, surprised that I couldn't find that anyone had done the same exact thing on the notebook and the designer, because I think if you're new to notebooks, that's the best way to understand how they work. Just seeing them side by side and seeing what steps are required.
Well, Heini, thank you very much for the session. There are not that much questions, but I have a few questions for you.
Go ahead.
You are building a notebook, and I think it would be great if I could turn that visual representation into a notebook. I'm not sure if that could be done. But after I have a model, how do I export it? Is that also part of the notebook experience?
Yeah, so if you're working with a designer, it actually gives you a choice to register that model. So then it will kind of export that model into that registry that is within Azure Machine Learning. And then if you want to publish it through or deploy it through Azure Machine Learning, then you can choose the compute platform that you want to deploy it. You could deploy it on AKS or so Azure Kubernetes Service or Azure Container Instances, etc. So there's many options then where you can deploy that. And that is, of course, the next step after you have your model ready.
Is it even possible to export it?
Yeah, you can totally export it out and take it somewhere totally else onto any platform that you'd like. Yeah.
That's great. Another question that I had is, we're doing all these steps in the notebook, and some of the steps, I think you put them in there for yourself just to check some little step in between. Are these automatically taken out, or do you have to, because they are not that optimal to the result, of course? How do you cope with that?
Yes, so this was for the training setup. So once you're actually kind of wanting to get to the phase where you want to publish the model and use it for just, because the kind of goal is to just have this endpoint that you give some data to and it just pops a number out for you. So you definitely want to just have the steps that you need. of course, like when we looked at those, they didn't take long, but of course you want to clean everything that isn't necessary then once you have the final product.
So there's some tweaking involved afterwards.
Yeah.
Running, okay,
Exactly.
take out the little things that are not necessary.
Yeah.
I see a question from Hassan. How machine learning models can be deployed using machine learning pipelines?
Yes. So there's a capability within Azure Machine Learning called pipelines. And within those, you're able to have kind of all the steps of your machine learning workflow included, from the data preparation, cleaning, etc., all the way to you actually publish it. So maybe we have 1 minute. I could show where you can get started with this very quickly. Because if I just explain it and say that thing in the right, there we go. So for example, if I look at my designer, here I could create a inference pipeline, and that will add a endpoint which can be called. So put data in, and it will also create the endpoint then that will give out data. So I could create a real-time inference pipeline out of this. So it could be called real-time. And that will start taking me through the process of creating this as an actual endpoint that can be called. So here's the web service input, and here's the web service output. And then I will, once I go through this all, I will get a URL that can be called. So that's how easy it is with the designer. Then with the notebooks, you do need to do a little more effort, but you can essentially, where we have this compute portion here, this is for running the notebooks when you're training them, but you can also have these clusters where you then have the actual web service running. So you could have it running on Azure Kubernetes Service, or if it's a very lightweight one, even in Azure container instances, and it will be just a REST endpoint that your application can then call. So that has to be deployed there.
And it's even possible to export it, for example, if somebody wants to play with ML.NET.
Yeah, exactly. Yeah.
Okay. Thank you very much, Heini, for your presentation. We are at the end of your session. Thank you very much.
Thank you.
We are also at the end of the second day of the Future Tech Digital 2021. I want to thank you all for being here, and of course, see you next year. Thank you.
Thank you, everyone.